Somewhere deep in the cypress swamps of southwest Florida, right now, a tawny cat moves through the shadows. She weighs maybe 100 pounds. She makes no sound. She doesn't roar. She can't. She might chirp or purr or let out a low whistle that carries through the palmetto scrub. And she is, by any measure of the word, a miracle, because she almost didn't exist at all. The Florida panther is the only documented population of pumas found east of the Mississippi River. And in the early 1990s, that entire population, every last one of them, could have fit inside a single school gymnasium. In the mid-1990s, Florida panthers were facing desperate times. Their small numbers, fewer than 30 animals in the wild, made inbreeding inevitable. Think about that. The entire remaining population of an apex predator, one that had once ruled the American Southeast, had been squeezed down to the size of a small-town baseball team. And they were sick. They were broken. And the clock was ticking. This is the story of how they came back. It involves a bold, controversial gamble that split the scientific community. It involves political fights that went all the way to Washington. It involves 8 cats from Texas who crossed state lines and changed everything. And it is, depending on who you ask, either the greatest conservation success story in American history, or a warning about how close we keep coming to losing things we cannot get back. To understand how the Florida panther nearly vanished, you have to go back to the beginning. Long before any of this became a crisis, the panther was everywhere. Florida panthers once occupied ranges all across Florida, Georgia, Alabama, Mississippi, Louisiana, Arkansas, and parts of Tennessee and South Carolina. These animals were apex predators across an entire region. Many Native American tribes of the southeastern United States, including the Cherokee, Seminole, and Miccosukee, considered the Florida panther an animal of great spiritual importance. For thousands of years, the panther was woven into the landscape, into the culture, into the very idea of what the American South was. Then Europeans arrived, and the panther's story became a very different kind of story. Following the arrival of Europeans, panthers were targeted as perceived threats to livestock and human safety, leading to systematic persecution. In 1832, the state of Florida instituted a bounty on panthers across all counties, formalizing incentives for their elimination. In 1887, the state of Florida offered a bounty of $5 per panther pelt, the equivalent of over $150 in today's money. Hunters were paid to kill them. Ranchers shot them on sight. Hunting pressure persisted into the 20th century, with panthers classified as game animals until a closed season was established in 1958. By then, the damage was catastrophic, and it wasn't just bullets. Habitat conversion for agriculture, logging, and settlement fragmented the panther's range, which historically spanned the southeastern United States, but contracted sharply to South Florida by the early 1900s as human populations boomed. Then, in the late 1930s and early 1940s, a white-tailed deer eradication program aimed at preventing the spread of disease to cattle greatly reduced the panther's main prey. The panther was being hit from every direction at once, hunted, starved, and squeezed out of its own territory. By 1958, hunters had gunned down so many that state game officials finally banned hunting them. But at the same time, rampant development was wiping out their habitat without any prominent objections. In 1967, the Florida panther was listed as endangered by the federal government. It almost was a posthumous listing. Some officials didn't even believe there were enough cats left to bother saving. But a small, exhausted population was still clinging on, deep in the big cypress swamp, in the Everglades, in the remote tangles of South Florida that development hadn't yet swallowed. And through the 1970s and 1980s, biologists began to collar them, track them, and document what was happening. What they found was disturbing. These weren't just rare animals. They were genetically collapsing. One of the morphological consequences of inbreeding was a high frequency of cowlicks and kinked tails. The frequency of cowlicks in the Florida panther population was 94%, compared to 9% in other pumas, while the frequency of kinked tails was 88%, compared to 27% for other subspecies. Those physical quirks were almost the least of it. In the mid-1990s, about 21% of Florida panthers had a heart problem called atrial septal defect, and more than 60% of the males had undescended testicles. Heart defects, susceptibility to heavy parasite loads, and reproductive abnormalities, including poor sperm quality and undescended testicles, could prove devastating. Geneticists were telling scientists the cats were so inbred they would probably only survive another 25 to 40 years. 25 to 40 years. From today, that would put extinction somewhere in the 2020s. You'd be watching it happen right now. So, what do you do? This was the question that consumed wildlife managers in the early 1990s, and the answer they eventually landed on was radical. Mimicking the historic gene flow that once occurred naturally between pumas in Texas and the Florida panther had the potential to alleviate these problems. The intent of this management initiative was not to replace the Florida panther's gene pool, but to create a healthier, more resilient population, similar to the historic population that had once roamed the southeastern United States. The plan was this: bring in female pumas from Texas, the geographically closest healthy population, and let them interbreed with the Florida panthers, introduce fresh DNA, break the inbreeding cycle, save the species. It sounds simple. It was anything but. The debate that erupted was fierce. On one side, geneticists and conservation biologists who had watched the data and were convinced the panther was in freefall. On the other, a faction that argued the intervention was unnecessary, even dangerous. The unreliable inferences about panther demography muddled the debate about the viability of the population, adding unwarranted credibility to arguments against genetic restoration. Some scientists claimed the population wasn't as small as feared. One researcher's papers never conceded that the population had declined to 30 cats, but claimed a population of 70 in the northern area had saturated the landscape. Then there was the fear of what biologists call genetic swamping, the worry that bringing in outside genes would effectively replace the Florida panther with something else. One concern was that the Texan puma's DNA would swamp that of the Florida panthers, effectively replacing one subspecies with another. If you introduce too much foreign genetic material, you don't save the subspecies, you erase it. Critics argued that the cure could be worse than the disease, and underneath all of it ran a political current. Development interests in South Florida had spent years fighting panther protections because a panther on your land meant restrictions on what you could build. Some of the loudest voices arguing against intervention had complicated ties to those interests. The science was being fought not just in academic journals, but in hearing rooms and political offices. Careers were on the line. Reputations were on the line. And so was the panther. A plan for genetic restoration and management was developed in September 1994. Scientists concluded that restoration of gene flow was critical to restoring genetic health to the Florida panther and ultimately recovering the species. The plan called for an initial introduction of Texas panthers, the closest subspecies to the Florida panther. In the plan, biologists outlined the need to introduce 6 to 10 panthers from a genetically healthy population of North American pumas in order to reverse the effects of inbreeding and achieve the desired genetic restoration of the Florida subspecies. In 1995, they did it. Scientists brought 8 female panthers from Texas into Florida. They were released into unoccupied panther range in South Florida. And then everyone waited. Would the Florida panthers accept them? Would the genetics mix properly? Would it work at all? Nobody knew. At the time, that theory had not been tested in a wild population of large carnivores, and scientists weren't sure it would work. This was, in the truest sense of the word, an experiment. The subjects were irreplaceable. There was no control group. There was no second chance. What happened next was extraordinary. Following the introduction, the Florida panthers successfully interbred with 5 of the 8 introduced Texas cats, and over time, their descendants showed fewer signs of inbreeding, such as kinked tails and reproductive issues. 5 of the pumas introduced in the 1990s produced at least 20 offspring. The kinked tails became less common. The heart defects declined. The sperm quality improved. The survival rates of hybrid kittens were 3 times higher than those of purebred pumas, 3 times higher. Let that land for a second. The offspring of the mixed population were dramatically more likely to survive than the inbred animals they replaced. The intervention wasn't just working, it was working beyond what anyone had dared predict. As one of the study's authors put it, it was a genetic rescue that led to successful increase in the Florida panther population, reduction in inbreeding, and actually documented growth in the population size. And what about the fear of genetic swamping, that Florida panther DNA would be overwhelmed and replaced? The genes from the Texas pumas didn't swamp out the unique Florida ancestry, scientists found. Instead, they reduced the effects of harmful genetic mutations brought about by inbreeding. Genetic analysis of offspring of translocated females found they retained on average between 59 and 80% of their Florida ancestry. The Florida panther was still the Florida panther, it was just healthier. The goal of genetic restoration was not to replace the characteristics that make the Florida panther unique, but rather to restore historic and healthy genetic variation. By 2007, the Florida panther population had tripled to an estimated 100 individuals that were more genetically resilient, from 30 animals teetering on the edge of oblivion to 100 in just over a decade. It is one of the most dramatic turnarounds in the history of wildlife conservation. Today, as of 2026, USFWS estimates 120 to 230 adults and subadults in South Florida. Many of those animals, many the descendants of the introduction program, roam southern Florida in Everglades National Park and Big Cypress National Preserve. From fewer than 30 to well over 100, possibly approaching 230. A population that was predicted to be extinct by now is instead growing. The panther is still here. But here's the thing about conservation victories. They are never final. The Florida panther currently occupies just 5% of its historic range. 5%. The vast territory these animals once commanded across the American Southeast has been reduced to a sliver of southwest Florida. And that sliver is shrinking. Florida panthers face serious threats, most of which can be traced back to habitat loss and fragmentation. Urban sprawl, converting diverse agricultural land to monocultures or residential and commercial development, and new roads and highways make it difficult for Florida panthers to find enough territory, prey, and mates. Roads are now the single biggest killer. After 2024, when 29 panthers were killed by vehicles, environmental organizations are sounding alarms as several large-scale developments continue to make their way through federal and state permitting processes that could eventually lead to more than 3,400 new homes in areas of Lee and Collier counties that include prime panther habitat. 29 animals in a single year killed on roads, in a population of maybe 200. And the genetic rescue, as miraculous as it was, may not be permanent. The benefits from the increased genetic diversity will likely be temporary, researchers say. Our simulations suggest that the benefits of the translocation may not last forever. Right now, harmful mutations are being masked by increased heterozygosity. But if the population stays small, like the current estimate of around 200 panthers, inbreeding could start rising again. Recent legal analysis notes that recovery plans require having 3 self-sustaining Florida panther populations of at least 240 individuals each, a goal that may need genetic rescue efforts to be successful. Experts suggest that introducing 5 to 10 pumas from outside populations every few decades could help maintain genetic diversity. The species needs room to grow north of where it currently survives. It needs connected corridors of habitat. It needs more wildlife crossings under highways. And it may, in coming decades, need another careful infusion of outside genetics to stay healthy. The story of the Florida panther is not a story with a neat ending. It is a story that is still being written right now in the sawgrass and cypress domes of South Florida. It is a story about what happens when a species is pushed to the absolute limit, and about what a small group of scientists, willing to take a risk and fight for what the data was telling them, can actually accomplish. As one researcher put it, this tells us a lot about the genetic underpinnings of an iconic conservation success story. The genetic diversity found was much greater than some scientists previously thought, and likely contributed to the recovery of Florida panthers after the introduction of the Texas pumas. Think about what it took to get here. A bounty that ran for over a century. Habitat gutted by development. A population so small it was predicted to be mathematically doomed. A scientific debate that almost paralyzed the people who could have acted. And then, finally, 8 cats loaded into crates in Texas and driven across state lines into a future nobody could guarantee. The Florida panther is not delisted. It is not saved in any permanent sense. Despite conservation efforts, the Florida panther remains one of the most endangered mammals in North America, and continued action is needed to ensure its survival. But it is alive. It is reproducing. Its kittens are being born in dense scrub right now, spotted and blue-eyed, growing into tawny adults that patrol territories their grandparents never could have reached. That is not nothing. That is everything. The question the Florida panther leaves us with is not really about cats. It's about choices. Every generation of humans that interacted with this animal made a choice. The settlers who put a bounty on its head made a choice. The developers who drained its habitat made a choice. And the scientists who looked at 30 sick, inbred animals and decided to try something audacious, they made a choice too. The panther survived because, at the last possible moment, the right people made the right call. That's the thing about conservation. It doesn't happen by accident. It happens because someone decides the thing is worth saving and then fights like hell to save it. If this story moved you, share it. Because the panther's fight isn't over, and neither is ours.